All right, well, good morning, good afternoon, good evening, depending on where in the world you happen to be. My name is Christopher Harrison. This is Web Wednesday, the show where we bring on some really cool people to talk about all things web dev. Now, today I'm really pleased to be bringing Aaron Powell back on to chat about TypeScript and about GraphQL. Now, TypeScript and GraphQL are topics that we've done in the past in sort of other places. Aaron was actually on to chat a bit about TypeScript and React, which is a fantastic coupling of those two things. And then we also had Jeremy Lickness on to talk about how you could create a Blazor app with GraphQL. So now we're going to take a look at it from the TypeScript side. So that way, if maybe you're doing JavaScript and still not 100% certain about why it is that you should be using TypeScript, hopefully this will really help provide a little bit of information there, but also just take a look at how these two technologies can come together. But enough of me babbling. Let's go ahead and bring Aaron on. So Aaron, thanks again for joining.
Thanks for having me back.
Absolutely. I see the sunlight and the fan there. For anybody who doesn't know, Aaron is in Australia, so apparently it's summer down there. I'm in Seattle, and it is decidedly neither sunny nor warm.
Yeah, it's overcast today, but it's a pleasant temperature. I don't have air conditioning in my room, which is why I have this little pedestal fan over the back there, and the door's closed. So otherwise, it would become a sweatbox, and you would see me just dripping with sweat by the end of this episode.
Yeah, I can understand that. And it does actually get pretty hot periodically here, especially of late. But yeah. Normally I would start with how you got into tech and how you became Aaron Powell, but we've done that a fair bit in the past. So let me just start kind of real quick before we get into the rest of it. Is what have you been working on lately that you're kind of excited about?
Yeah, GraphQL has been really quite dominant for me for the last 18 months to nearly 2 years in terms of looking at the applications that we've got for it and how we can use that. Throughout the end of last year, I was actually looking at GraphQL from the headless CMS space. So projects like Strappy and Keystone.js and things like that are ways to kind of build GraphQL servers, but without having to kind of go to the details of what we'll do today, where we're building everything from scratch and provide that sort of stuff into the a website that you're building or a mobile application or whatever it may be. Yeah, I've been doing a lot of stuff on GraphQL still, and of course React, because I'd be remiss if I didn't have a little bit of React in my life.
I can appreciate that. Although I've found myself these days really gravitating a lot more towards Svelte over React, but just a matter of personal preference there.
Yeah, it's been on my backlog for so long. I feel like it's just one of those. It's that to-do list backlog that everyone has, and you're like, oh, I'll totally get to them, won't I?
Yeah, I certainly feel that. So let's, I do want to define a term, because I really do try to take that Scott Hanselman approach of let's always make sure that we're defining our TLAs. And for anybody who's not familiar, a TLA is a 3-letter abbreviation or a 3-letter acronym. You mentioned CMS earlier. What is a CMS? Just define the term real quick.
Yeah, no, it's a good point. And I try to be better at that myself. So a CMS is a content management system. So if you think about a website, whether it's a brochureware website or an e-com platform or any website where you've got text, you need some way to get that text to people. If you've got a dynamic website, you probably want some way that you can do that fairly dynamically, and you don't want to be relying on developers to constantly have to go in there and, we need to update this product name, or we want to change the description of a person on our website. You don't want a developer to have to do that every single time. So this is where a content management system will come in. You have some kind of editor-friendly UI that they can, a non-technical or a less technical person could come in, edit that, and then make that available to the consuming systems downstream. Okay,
perfect. And then the other term that you mentioned, and I think this is a perfect segue then into our conversation, is you obviously, of course, mentioned GraphQL. Now, we do have other videos on GraphQL, and I'm going to go dig up the link here in a couple of minutes, so that way I can post that into chat. But what is GraphQL?
Yeah, well, so maybe rather than kind of hand waving descriptions, can we jump to the slides that I've got?
Yeah.
And let's just use some diagrams to kind of talk through this and a bit of a conceptual model. So fundamentally, GraphQL is a way to communicate and get data out of our backend systems. So let's say that we're building a quiz application. So I started building this prototype and this demo application that we're going to have a look at shortly throughout lockdowns, and when the only way that we could with our friends was through like some form of video conferencing platform where we were playing quiz games. A quiz game, like how hard could it be? So we're going to have to model a bunch of different data for that. So let's start off with a quiz. We're going to have some way to identify that quiz. That's going to have some players. We might have state, like is the game waiting for players to join? Is the game in progress or has the game been completed? And then we've got questions and answers. So then this becomes, we might have like a relational data model on this. So we have our player, a relationship to that. So we can go from the quiz, we can get back to the player. But a player also has a relationship to the games or the quizzes that they've been involved in. Then we've got questions that are there. They're attached again to our quiz, and they've got a series of answers that could be presented because it's multiple choice. One of those is going to be listed as the correct answer. So this is just a data model that we're working with. Now, commonly we would expose this as REST. Like this is the way that I traditionally built applications, was building REST-based APIs. And that's what a lot of the audience might be familiar with doing REST. And that we tend to expose as a couple of endpoints. So we might have a quiz endpoint where you can get back all the quizzes. Maybe that's an admin feature. Or you get back a quiz by its ID. And we get back players by their ID, or questions and a question by their ID. So it's very much structured around the data model itself.
It seems very restrictive. Like I can do this, but I can't do something else.
Yes, exactly. And that's kind of where GraphQL comes in. So GraphQL, and a 30-second history lesson for people that are very new to GraphQL or haven't been following it prior to today. GraphQL was actually created by Facebook to solve problems that they had with the way that they were doing data-centric APIs. Now, since then, it's been handed over to an open source foundation called the GraphQL Foundation. They're actually in control of GraphQL as a language. So GraphQL is really just it's a language of how to communicate between a client and a server. And where you're correct there to say REST could be a little bit restrictive because the server is very much in control of the way the data is exposed. In a GraphQL system, a client is the one that's in control of how the data that they want to get is what data that they want to get. So a server is still going to say, like, here's the things you can get. You can't just magic up data out of a GraphQL server. But the client can say, well, I want to get back, well, and this is a GraphQL query, and I guess to kind of illustrate that, the server says, well, you can get back games by their ID, or all of the games, or player results. And then from this, we can then follow through our data model. So I can say, from a game, I want a game by its ID, but I only care about the players that are there and their names and maybe the game ID itself. So instead of from a REST standpoint, we'd have to hit the game endpoint, we'd pass it the ID, we would then get back that, we would then get back a series of player IDs, we would then hit the player's endpoint and we'd pass through each of those IDs. And we could be requesting, like it could, there's an n number of requests that could happen here because we don't know how many players there are, and all just to get back a list of names of who is actually playing our quiz game. Okay. So that's where GraphQL, I guess, is different, and it gives a lot more control to that client because instead of having the server saying, no, you have to make multiple requests to get the data, the client says, this is the request I want and the data I want back from that request. You kind of figure out how it happens.
Now, I might be putting you on the spot here, and if I am, you can totally pass on the question. But I do want to ask it. Is I know that there is another protocol that's there called OData, or Open Data API, I think is what it stands for, which does something very similar to this, where it allows the client to craft a query, and if I remember right, like craft something that looks very much like SQL and be able to send that over. How does GraphQL differ from OData?
So you're right that there is definitely some analogies that can be drawn between the two of them.
Okay.
Probably the primary difference is that GraphQL is designed to be more of an abstraction over the concept of how you can access data and it's not prescriptive about what that backend system is going to be doing and how you get it. So you don't really have a query language in the same way as you get out of OData. OData is much more around you're hitting an endpoint that you provide a very structured query to it, and then you're expecting your endpoint to potentially translate that query into like the underlying query language. Like it is SQL-like, but maybe you're not executing SQL directly.
Right.
But at the end of the day, it is still putting more power in the control of the client, but the semantics of the way the server works with those are a little bit different. At least that's my understanding of it. I'm sure there are lots of better articles out there that will do the service of explaining the differences between OData and GraphQL. And I've been known to make quips that GraphQL is really just OData for JavaScript hipsters. But that's kind of
All right.
it's sort of downplaying the significance that GraphQL has.
Okay. All right. I dig it.
Yeah.
Okay. Yeah.
So I guess I hopefully that can give people an idea of the sorts of things that we're going to be looking at in this when we jump over to code and start building out an application. And see where GraphQL can be powerful in this space.
Now, I do want to highlight real quick here is when I'm looking at this, I'm immediately thinking this is a perfect use case for TypeScript because, for anybody who doesn't know, the great thing about TypeScript is I can define interfaces or I can define types. And by the way, those are weightless. So they're actually like removed when it's converted into JavaScript. And so now I can get a lot of that IntelliSense and a lot of that autocomplete and kind of be able to structure and know what my objects look like when they're coming down. And it feels like, with GraphQL, I could be sort of like flying without a safety net, if you will. But now with TypeScript, I can now get that safety net. That type safety pun was not intended, but we're just going to go with it.
Yeah, and this is I very much agree with you on that idea that TypeScript does lend itself quite nicely because if you're looking at this, and obviously this is a very subset of a larger GraphQL schema, and we write a schema in GraphQL that represents what the server is capable of exposing to a client. And you can see that top bit here is we have the type keyword and then query, and then like there's obviously something here, like we've got some data models that I've obviously custom created, like game here, and there's syntax that so the exclamation point or the bang operator here is indicating that something cannot be null. We've got square parentheses, which are, as a developer, I just immediately know that's going to represent an array or a sequence or something to that degree. And so we can see that there's probably something here that is implying a type system from a GraphQL schema. So being able to pull that across to TypeScript, I think makes just like a good bit of natural sense.
I would agree. Before we get into the demo, there's one real quick question that came up, which I think is good to ask. So over on Twitch, Sean2416 asks, when should we not use GraphQL?
Yeah, and that's a great question. So there's definitely been a huge trend, particularly in the JavaScript space, of going towards GraphQL. But the thing to be, to be mindful of is GraphQL, the same as REST and the same as OData and the same as custom built APIs. There are going to be use cases that it's right for and use cases that it is not right for. It was originally created by Facebook, as I said before, and not everyone has Facebook-style problems. So a solution that was designed for a Facebook-style problem doesn't necessarily match for everyone. Scenarios where it's not going to be ideal, at least, and again, part of this is going to be my opinion, so take that with a grain of salt, is that GraphQL is quite difficult to create a really secured API because it can be so exploratory. So in the case of this query that I've got on the bottom on screen at the moment, we're starting with a game object, which then has a relationship to a player's object, and that might have a relationship to something else. Well, how do we ensure that an authenticated user has access to only the data they're allowed to see? Like they can't see the email address of a player that's not themselves. So this is kind of like row-level security you're almost thinking about inside of a database, but the client doesn't know that it has that level of security. So how do you make sure that you're enforcing that? And this can be something that is quite difficult to do with GraphQL. The language itself is not necessarily designed to do that in the way that you might expect it if you're coming from REST or from building custom APIs. So that's where it might not be the right solution for you and the kind of applications that you're building. The other is if you're working with something that has highly nested data, because I can, I guess to use another kind of a programming analogy, I can dot through objects. So I could start from, and we'll actually see this in the schema that we're going to build. From the game, I can go to players, which can then go back to games, which can go to players, which can go to games, which can go to players, which can go to games. So you can see the recursion that's happening. How do you stop someone from essentially DDoSing your own, so creating a denial of service attack on your own infrastructure because they've created a query that's a recursive query?
Right. Right.
Yeah. So it's something to be careful of with your designs. It's not to say that any of these are like deal breakers. They're just things that make it potentially the wrong solution for a problem that you might have.
Okay. That makes a lot of sense.
Yeah. So hopefully, Sean, 2416, that has helped answer the question for you.
It answered it for me, so
that's good enough.
We'll go with that.
Yep. All right. Well, we've been on for 15 minutes. Maybe it's about time we do get across to some code.
I agree completely.
All right. So I'm going to jump to before I jump to code, I'll just jump to the browser. So for the code that I'm going to be showing, we're going to jump through various sections of a workshop that I've created around doing GraphQL with TypeScript. You'll find that link on my GitHub, github.com/AaronPowell/GraphQL TypeScript workshop. And I think Christopher is frantically typing that into chat to send out.
As a matter of fact.
Ta-da! But if you want to follow along or you want to do this yourself, feel free to clone this repository and jump through it and play around with the code yourself. But without further ado, let's jump over here to VS Code, and we're going to start at the very start. So this is the first step of our workshop, and I've kind of dealt with some of the boilerplate of this. So it's got a scaffolded out React application. It's got a scaffolded out API application where we're going to be building our GraphQL server, and that's using Azure Functions. I've also set up a dev container for this, so that will pre-install the Azure Function runtime and all those sorts of things. It'll set up all the tooling and VS Code extensions that you might want. For me, that's the quickest way to get up and running. I love dev containers. I could probably do like an entire hour just talking about how cool they are and why every project should have them. But you're not here to learn about dev containers. You're here to learn about GraphQL and TypeScript.
We actually had Burke a few weeks ago to talk about dev containers. Cool. Yeah. It was a lot of fun.
Go watch that episode instead.
Yeah.
Because there's nothing worse than watching someone fat finger things while they're trying to type out commands in a terminal or in VS Code or anything like that. I'm going to cheat and just use the instructions out of the README. But the first thing I've done is I've gone to the API folder, and then we're going to install some node packages. So I'm going to be installing the Apollo Server Azure Functions library, and I'm going to install GraphQL. So let's just kick that off. And I'll talk a bit about what those are while they're installing. So Apollo Server is an implementation of a GraphQL server, and they've got bindings for all sorts of different hosting platforms. In this case, I'm using Azure Functions just because I kind of like the programmatic model of Azure Functions. But if you wanted to host it in, say, an Express application or Koa or like any other serverless platforms, like they've got bindings to do all of that. So like I said, I've gone Azure Functions just because it was simple and super easy for the workshop that I wanted to do here. But the stuff that I'm covering is not going to be Azure Functions specific after we kind of set up the Azure Functions.
Okay.
Cool. All right. So they're all installed, and now let's create a Azure function. So yeah, like I said, let's not do anything that's Azure function specific, and then I go and create an Azure function. So,
and for anybody who's not
out of myself.
For anybody who's not familiar, npx is a command that will actually allow you to run something from a package, run like a command line from a package without actually having to install that package.
Yeah, and what this is doing is it's using the Azure Functions command line tool to create a new HTTP trigger template and calling that GraphQL. And I think that's running, or is that? Yeah, okay, there we go. So that's done.
Took just long enough to make you nervous.
Exactly, yeah. Well, because I've run through this so many times, I know where things should take. Oh, whoops, where have I gone? I've gone to the wrong screen. There we go. I know where things should take a while and where they shouldn't, and that shouldn't have taken the time that it did, but all good. Here we go. We have it in our editor here. We have our GraphQL Azure function defined. We have the index.ts and the function JSON. The only thing that I have to do custom for Apollo and Azure Functions is I need to change the way the output bindings of Azure Functions works. So this template, when I scaffold it up, it will want to output to a variable named res. Because Apollo doesn't know that it's going to be called res or response or the thing I want to send to my client, it expects it to be a return value from the Azure function. So Azure function either return a value or it can be as an output in a variable. So I've just got to change that there. So that's what the $return represents. And now we can close that file off. Cool. So I'm just going to come down and grab some code. Whoops, where am I? Sorry, I'm scrolling around like a mad person. Here we go. So let's just start building out our GraphQL GraphQL application. It's going to be super simple. I'm going to delete everything here. I'm going to import Apollo server and the GQL. So GQL is a template literal that allows me to create the GraphQL schema. So I've created a super simple schema here. It has a type called query, and that is going to have a thing exposed in that query called hello.
And that's not a TypeScript type that you're creating, just to confirm, correct?
Correct. So this is a GraphQL schema type.
Okay.
Not TypeScript or anything like that. So I've got an extension. So the dev container will actually install the extension for GraphQL. It will be give that syntax highlighting here inside of the GQL template literal.
Okay.
I've then created a resolver. So the resolvers are the things that are going to handle what the GraphQL schema can do. So that is so that's why it actually matches the same structure. So you see it's got query here, query, hello, and then this is the function that will be executed when we hit that. And then we have our server using the Apollo server. I give it our schema, our type definitions, and our resolvers. It's going to smash them together, and then I expose the an Azure function that we can use. So
that looks very similar to just like spinning up, say, an Express server or a Restify server.
Exactly, yeah. So it's like there's not really any kind of Azure function semantics that you care about. Kind of once you get into actually building it. So now that like we've set up the basic Azure function, we've told it how it's going to return the value to the client. It should be all good from here.
Okay.
Now let's just see. Okay, so this is just so this is written in TypeScript. So it's just compiling that down. It should be up and running, and it looks like that we have had an error. Yay! I've got a incompatible version of Node. That's an easy fix. npm install 14 because I of course have updated to Node latest inside of this dev container, and then we'll do npm use 14, and we'll do npm start.
So we're really cooking here.
Yeah. Yes.
Everything,
but hopefully this doesn't explode a second time. Excellent. There we go. Our server is up and running. Let's pop this into our browser, and we'll zoom in. So, Apollo has a sandbox playground where you can test out queries. So let's go over and do that. And fingers crossed that I'm going to have to zoom this one in as well. Here we go. Okay. So it has, so up here it's just got the HTTP endpoint that we're hitting with our GraphQL server. And we can see that it's picked up what our schema looks like. So we have this root type, which is called query. It has a field called hello. And if I hit test query, we get hello from our GraphQL backend. Woohoo! We have made our first GraphQL server. It's returning from our Azure functions. I could, if I wanted, set a breakpoint with inside of here. Oh, I'd have to breakpoint inside of there. Never mind. I won't. But you kind of get the idea. Like you can see that we've proved the concept. We've built a GraphQL server. So let's kill this and let's jump forward in time a little bit with inside of our workshop and have a look at another step. So just kind of for this sakeness of time, not going to go through all 8 steps in real time. You can do those yourselves afterwards if you want. Instead, we're going to jump through to step number 4, where in here I've actually gone and built a bit more of our Azure function. So what I've done here is I've extracted out the schema into its own file. Sorry, this is the file I actually wanted, not the index.ts. And this is a much more rich, complex schema. And to the point that you made earlier on, Christopher, is that you'll see that we have what kind of looks like a type system. And it's a little TypeScript-esque, isn't it?
Yeah.
We've got a type question. This kind of looks like a type in TypeScript. Like we don't have equal symbols and things like that. But we've got scalar types, we've got strings, we've got arrays. If I come down to the game, we can see there's an array of players, which is referencing this type down here. We've even got enums and stuff like that. If I come right down to the bottom, here's what we had with inside of our slide deck. So there's those types that are exposed by our query. And then a schema, which just says, well, here's kind of your entry point. This is how you're going to work with our underlying systems.
Okay. I dig that. All right.
Yeah. So I've also refactored our Azure function kind of entry point a little bit. So we now, instead of having that GQL and that schema kind of embedded in the TypeScript file itself, I'm loading that from this external file. So we'll see that it's just loading it by walking some directories and things like that. And then we're going to add some resolvers to it. And the other thing that I've also done is I've created a data structure that represents how we would store the data for this for our backend system. The workshop has an in-memory data store, or it can be connected up to Cosmos DB, like if you want persistence. At the moment, we're just going to be using in-memory, just so I don't have to worry about setting up Cosmos DB and things like that. The in-memory one also has some static data and stuff that it scaffolds up, so you end up with some basic questions and so on and so forth. But yeah, let's go ahead and actually handle what our new schema kind of looks like, because I put out this resolvers file here, and well, we can see it's got kind of nothing in it.
So what is a resolver?
So a resolver is going to be handling what our schema says that it can do. So we need, at the moment it has, I can get a game by its ID, I can get back games, or I can get back player results.
Okay.
Well, how do we do that? Like, how does it know to translate this to, say, a Cosmos query to get back a game by ID, or to walk through an in-memory model? Actually, just before I start, let's just check the node version, and it's at 16. We'll do nvm install 14. I think I could probably down level the 16 a little bit. I can't remember what version of 16 is supported by the node tools, so the Azure function tools, but we'll just use 14 because I know that's safe. Oops, nvm use 14 and npm. I just wanted to start the server in the background because it will take a few seconds to get running while we go ahead and try and build something. So
okay.
Let's just pop this to the right, split editor to the right. Close that, and then let's handle what that query can do. Because at the moment, the server will start, but if we try and hit any of these endpoints, it'll kind of just explode because it doesn't know what to do. So let's start with games. We need to, how do we handle games? So I'm going to need to, I know that I need to make a function here. And this is going to be a function that returns something. But, what arguments does it take? I don't know. And I don't have any type safety. And I guess you can kind of see where the breakdown is starting to happen with our TypeScript. We're starting to lose some of that value because I don't have any type information here.
Right.
Now, because I've worked with Apollo, I know that there are some arguments that come into this resolver. The first is going to be the parent of this resolver in the resolver chain, because resolvers can be nested. So from a game, if I want to get players, how does it kind of follow that hierarchy? That'll make a bit more sense later on when we fill this resolver implementation out a bit more. But there's a parent. I know I don't need it, so I can just kind of ignore it. The second argument is arguments that are passed to this resolver. Now, games doesn't have any arguments, but game does. So I can just ignore that. And then, I need some way to access my data stores. Well, I've set this up so that it is injected via the context of the resolver. So I know that I can do data sources here. Sources, because, I wrote the code, so I know what comes next. So I know that all works. And I know that I can do return data sources dot game dot, or is it games? I don't know. But you notice that I don't have any IntelliSense here. I'm not getting any type safety. But I think it's get games. I think that works.
Only one way to find out.
Exactly. And then I know that I need to implement game, and then I can ignore the first argument. I know that I have an ID that comes in here, and then I know that I'm going to get data sources, and then I can return data sources dot get game by ID. At least I think that's what it's called. So, but we don't know, and we've really lost any value that TypeScript is kind of giving us here.
Right.
Cool. Our server is up and running. But yeah, so let's see if it did work. So we'll come back to here. We'll restart, reload our sandbox. Let's see, it's still got the old query here, but it's telling us that hello doesn't exist anymore, so we can delete that. We'll come back up to query, and it seemingly hasn't picked up what our query should be, which is somewhat annoying. So let's come back into here. Let's just reopen this one in the browser. Now, of course, it's on a different port. API GraphQL. Oh, no, not 3000. What was it? 7072. 7072. Query our server. Come back over. Okay, cool. So we found all
that
the
looks
things
better.
There. Yeah, that looks a lot better. Let's get back all of the games, and we can see as I can kind of navigate through this. And let's say I want to get game by the ID and the state, and maybe I want like players, and I want the player names. Let's hit query. I don't actually have any data, so seemingly I got all my API calls correct. So it did actually return something, but because I didn't have any data in there, it's just returned no values. But just I'm going to say sheer dumb luck, I managed to type all of this correctly.
Well done.
Yeah. But I hope that those of you that are watching and Christopher yourself, you can kind of see that, we've lost kind of value here. I know what these things are, but I've got just there's any's all over the place. And at this point, we may as well not be using TypeScript. I may as well just be using plain old JavaScript to write this because TypeScript has ceased to give me value.
Yeah, I think that's like just a good general rule. Like there absolutely is a time and place in TypeScript to be using the any data type, but to quote Martin Fowler from his famous refactoring book, code smells. That if you're doing that, it's a smell. Like it's an indication that you're probably not doing the right thing. So if you're using any in TypeScript, you're probably not doing the right thing.
Yeah, exactly. So we'll just go. Let's go through the process of install Node 14.
While you're doing that, Sean, 2416 had another question, which is, can GraphQL queries be cached by browsers? And I guess my sub-question to that would be, could you then use GraphQL to subquery the data that was returned?
So the answer, I mean, yes, because anything that is HTTP input could theoretically be cached by a browser. More likely, you're going to be using a GraphQL client-side library that will have a form of caching built into it. This might not be maybe persistent across sessions, but if someone is like within inside of a single-page application and they're navigating around that, the requery might be cached just locally on their machine for that session. Additionally, on a server, you would potentially be using a cache of some form to optimize for particular styles of queries and particular query results. There is a startup that launched last year called GraphCDN, which is a GraphQL CDN designed for doing this sort of stuff. So like you kind of sit that in front of a GraphQL server to do caching, so you don't kind of have to build it yourself. Yeah.
Okay. I appreciate that. And Hiroja, it sort of like leads us in perfectly. It's like, is there an appropriate type which we can add to the resolver variable to get some support? Which is,
yes,
as a matter of fact.
You've read my mind. So I've jumped forward again to, well, let's look at how we can leverage type generation. So there's kind of two schools of thought when it comes to type generation. And I'm just going to jump through my slide deck to Control G. Nope. I'm going to jump through to a slide. And I can't remember what the shortcut in PowerPoint is to jump forward in slides. But I did actually have a section on generating types. So there's two ways you go about it. There is a schema first model. And so schema first is, well, we have a type system that's represented within inside of our GraphQL schema. They kind of look like our JavaScript primitives or like our TypeScript type definitions. I mean, they're not exactly the same, but they have some clear, I guess, influence on the way like that kind of a type system works. And a schema-first approach allows you to have a really clear separation between the types that are in your schema and the application that you're building. So you don't end up with it being overly bound to each other. I like to use a tool called GraphQL Code Generator to go ahead and do this generation. And we'll see this in action in a little bit. Alternatively, there is a code-first approach that you can do this. This is really popular in strongly typed languages such as C# and the libraries that support GraphQL and C#, but you can still do it with TypeScript. So we create our TypeScript type objects, so our classes and things like that, and then we extract the type definitions from those to then generate our schema. So we're using our TypeScript types to build our schema rather than our schema to build our TypeScript types. So that's code first versus schema first. So this gives a really clear relationship between the way our types are defined and the resolvers that are there. Oops, my audio just went silent. I don't know if that's for any particular reason.
No, you're still good. Yeah, I had muted my Mac for a second.
Ah, okay, cool. I was like, wait, did my browser just die? I'm not sure. But if you're looking to go the type first route, typegraphql.com has it's a good strong open source project to do this sort of stuff. It uses decorators in TypeScript to do that sort of stuff. And yeah, so you again pick whichever model works best for you. I prefer schema first, and that's the route that we're going to go when I go back to the code over here. So this is GraphQL Code Generator, and I'll bump that a touch more. And this is just on their website. They've got a little sample here, and where's my scrolly thing? Here we go. So we have a simple little schema that they've defined. It's got some types in here. It's got some enums. It's even got interfaces and unions, so other things that I'm not touching on inside of this demo today, but more advanced features of GraphQL's query language. And what we can do with this is we can generate using their generation tool a bunch of TypeScript types. That's here on the right-hand side. Now, if we have a look at that, it kind of you can see where the similarities are. So let's go back to the top here, and we have our query type, which has me, user, etc. We'll see there's me, and we've got user, which is optional as a result that we can see there because denoted by our question mark operator. We've got an enum that's down here. We have a union type as well. And okay, this actually, it looks very much like a kind of thing that we'd be doing for GraphQL. Sorry, for TypeScript if we were writing this ourselves. So let's go ahead and add that into our project. So again, for cheat's sake, I'm going to copy and paste from my notes. We're going to install the GraphQL CodeGen CLI as a dev dependency of the API project. And then we will use the GraphQL CodeGen init command using npx to just execute that out of the local package. Give this again a minute to install the myriad of node modules that we will be needing here.
Is the is that browser? So if I have like my GraphQL query written, can I just copy and paste that into that browser window, and then it will just generate the TypeScript for me right there?
Yeah, for sure. Actually, we can have a look at while we install our node packages. We can actually do that.
Yeah.
So we'll just paste that in here.
Look at that.
So look at that. Yeah, super fast. So GraphQL CodeGen it's not just for TypeScript. It actually will do a bunch of other languages. So we can do we can generate C#, Java, Flow, JS. You can get it to just give you like an AST. So you could do that for your own custom ones. We can. This is a tool we'll also use for integrating into React a little bit later, if we've got time. Otherwise, we'll look at a completed version of how we can do that. But yeah, it's a lot of it's really powerful in what it can give us.
That is really cool. We've got about 15 minutes, so we still have a fair bit of time.
We've still got time. Okay, so let's initialize our schema. Sorry, our code generator, and it's going to ask us kind of what are we doing. Well, at the moment we're building a backend API. Where is the path to our schema? And I get exactly where this is. So it is at /GraphQL/schema. So you could actually do this to a remote schema. So if you're building something that was like just a client-side application, just like a React application talking to a backend, yeah, you could do that. But I've got a local schema instead. We're going to generate TypeScript and TypeScript resolvers. And we are going to put this into a file called GraphQL generated TS. And we'll generate an introspection file. We'll call it CodeGen YAML, add script, we'll call that gen. Okay, so those last commands that I quickly jumped through. So an introspection file is a thing that can be used by other GraphQL servers to interrogate your GraphQL server. I tend to generate just because it can be a useful thing, particularly for a demo application such as this, but the sort of thing you might not want in a production system. It uses a YAML config file. If you really detest YAML, you can use JSON configs, but just by default it wants to go YAML, and then it will add a script to your package JSON that will call whatever you want so that you can run the code generator. I've called it gen, so we can just do npm run gen when that is completed. So this has added a bunch of dependencies. I just have to run an npm install to make sure that they are all actually installed. And give it a moment, I can do npm run gen, and we will end up with a brand new file, generated.ts, which is the same thing that we had with inside of the browser just a moment ago. We see that we have a bunch of custom types for like maybe and exact. We have our game type and our game state as an enum player, so on and so forth. But what I've also done is I've told it I want to generate GraphQL resolvers. So I can come to my resolvers.ts where we had our inherently untyped information. And if I was to go resolvers, there we go, import that. And now we have a whole bunch of stuff that has been added. Type safety. So if I hover over our ID parameter. Now we remember that we knew that should have been a string because that's what we had in our schema. It was an any because we didn't understand the type system. But now that I've generated resolvers from our schema, it knows that game has a parameter of ID passed in, and it is a string. Magic.
That's very cool.
Yep.
Now,
same with player result. Yeah.
One real quick question, and I want you to keep going in there, but I do have one real quick question now that I've interrupted you. Is as you were going through the list of choices, one of the things that I noticed is it did give you support for MongoDB. So if I choose that, what will that add? Will that also add like the client code to call out to Mongo, or does it add like specific types that Mongo might be looking for?
So what it'll do is it'll generate, so I haven't played around with it a huge amount, so I've only kind of seen that, actually, rather than me talking through it, I think I can get it to, in here, MongoDB models. So this is what you'll get when you do that. So you would end up with, here's our, our object ID from Mongoose.
Okay.
So we end up with the base models that we would be using to then store. So that's the kind of the primitives that you would have. If you wanted your GraphQL schema to 100% map through to your downstream model, that's what it would do. Yeah.
Okay. That actually makes a lot of sense. That's really cool.
Yeah.
Okay.
Yeah. But obviously the risk you're running there is you're directly exposing your backend data structure to the client, and that may not be something that you want. So that's just I'd say that's a thing to be mindful of.
Right. Okay.
Cool. So done. We're getting there, but we still haven't managed to add type safety to our data source. Like it's still an any, and that means that answers is an any, so we're ending up with any's when we're trying to do a filter. So like, I know this works because I wrote the backend code, but how do we make sure that we can get that stuff all done? Well, I'm going to jump through the completed version just because for the essence of time, but I'll look at all the important pieces as they come together here. So the way that I can do that is we're using what's called a context in Apollo. So Apollo has the ability to insert things as contextual information into a resolver, and we create a context object that represents that. And I can statically type that, and I've called that Apollo context because I'm highly imaginative, and I'm saying that our Apollo context is going to have data sources, and the data sources has three properties on it: user, game, and question, and they're interfaces. So that's just an abstraction so that I could swap between in-memory and Cosmos DB implementations. When I set up my Apollo server, I give it the context here. I give it the data sources here that is then added to our context. And then, I need some way to tell the resolvers to be aware of this, and tell the generated resolvers from GraphQL CodeGen to be aware of this. So inside of the CodeGen schema file, I can extend the way the generation works by saying, here is a context type. Here's the file that it is, and then that's the name of that's the thing that's being exported for that. Similarly, I might want backend data models to be slightly different from my client-side data models. So, for example, if we have a look at the data model for our question. So our question has question, category, incorrect answers, correct answer, type, and difficulty. But in our schema, our question only has question, correct answer, and answers. There's no indication of the incorrect answer. We just get back a set of answers which contains the correct answer. Also, correct answer doesn't have an underscore in it. It's camel case, not underscore case. I forget which one what that one's called. So we need some way to kind of map those through. So so what I've done is inside of the
snake case, that's what it's called. But
Snake
the
case,
underscores, yeah, it's snake case.
Yeah,
Took me a minute to remember that as well. Python uses that.
Yeah, I'm very much not a Python person. I know that you are, so you're more likely familiar than I am. So So again, in the config, I'm mapping, when you find a question type within inside of my schema, the resolver is capable of working with this question model, which is my backend, but it's going to ultimately return the schema object. So I have to do my own custom mappings there. So how does that work? Well, I've expanded out. So I've run the GraphQL code gen. Now it's detected that I've got a context type, and that's what the context type is. And you'll see that now we have IntelliSense there. Or sorry, we have type information there. Data sources is strongly typed. It has user, game, question there. Those interfaces. I can see on game is an iGame data source. It has get game, which is get. So it was actually get game, not get game by ID, which is what I'd originally thought it might have been. So that one would have exploded on me. But I can see that it's there. I can see that it returns expects an argument, which is a string, and it can return a promise. I now can await against that because I know that it's an async operation. I get back a game model that I can map, and so on. We're really getting some powerful type safety here. And then I can come down to my question. So a resolver, while we'd initially been looking at resolvers for how we do the entry point query, so the get game or games and things like that. Well, I have to do some mapping between our backend data model and our schema data model because, well, we have answers, but answers is an amalgamation of the incorrect answers and the correct answer. So inside of here, I do answers, and then I just concat them into a single array and then randomize them. Or for correct answer, I do a model mapper of correct underscore answer, so the snake case to the camel case, so on and so forth. So, but this knows that the question that is received is the backend data model, but it needs to return something for our schema model. So yeah, we're getting a lot of good type safety that is helping us understand the differences between client side, server side, backend data store, schema data design.
I appreciate that. And so now everything has a type. So as you go in and start to continue to add features and add functionality, it's now just a matter of, dot whatever, and VS Code is then going to help you out and help guide you that whole way through it.
And the TypeScript compiler is going to help out as well, because if I was to, if I still had up here get game by ID, I could.
To a certain extent, that's like perfect that you had the typos in there because you're getting the red squigglies.
Yeah, but now I'm getting the red squigglies because get game by ID doesn't exist. And if I was to run the TypeScript compiler, so if I was to run TSC against this, it would also give me an error because that doesn't exist. So I now get that type safety, whereas I previously didn't have that. Look how many times I got it wrong. Now, I know that we're getting close to the end, but I do have one other thing that I want to show, like where the power of type safety can really get, and that's when we start building out our client as well. So this workshop, we end up building a React UI over the top of this. But the React UI needs to talk GraphQL, and, well, we kind of want it to talk the same schema language that's been talked by our server. So that we get the same data models. We know that if I added a field to our schema, that the client would be aware that that field existed. And if I was to change the casing of something or I was to remove a field, we'd get all of that. So what I've done is I've actually created a bunch of queries these are the queries I want you to be able to execute. And this is a common pattern in GraphQL. You would create operations, as we tend to call them, that you expect the client to be able to call. And these are ones that you've potentially optimized your server for. So I want to create a new game. So a mutation is how we create data, whereas a query is how we get data. Sorry, a mutation is modify state on the server. A query is return state from server. So this mutation, we're creating a game, and we're only going to get the ID back from here. Now, I want to be aware of that operation, and I want the type safety of that when I come to the create game React component. So I have added an extension to the GraphQL code generator that allows me to generate React, generate from these operations things that I can use inside of React, and then I can combine them with the Apollo client, which has React hooks. So I've just got a use mutation, which is a React hook provided by Apollo client. I've then got this create game document, which is something that has been generated by GraphQL code gen, which is it's kind of a syntax tree that tells GraphQL, it tells Apollo client how to execute a GraphQL operation. But it's type safe. It knows that if we execute that, it's going to return me an object which has create game when executed is going to have some data that's available from it, which if we eventually unpack all the way down here, and I'm just doing a bunch of null checking, so we're not loading, we have called it, there wasn't an error, and the error and the data did have create game returned. Create game has a property called ID, which is a string, which is what we expect based off of the operation that we'd previously defined. I know that was highly rushed and very condensed look at how we can add type safety at a client level, but in this React application, we are aware of something that is provided by our GraphQL server that has, we can see the type safety kind of all the way down to the end of that. Yes, that's
No, that's perfect. I was just pasting the workshop link in. Yeah, yep. Yeah. No, I appreciate that. And it really, I also think it really just highlights, again, that great advantage of TypeScript is that now you have that type safety, you have the IntelliSense, like you have everything that you really want. So that way you don't have to remember, is it, get game or get game by ID? And you can do that, from the server all the way down to the client and back again.
Yep, exactly.
So yeah, no, I appreciate that. Cool. So where can people find you? Where can they find more resources? So
I think you've pasted into the chat the link to the workshop. So that, as I said, that's on my GitHub, github.com/AaronPowell/GraphQL TypeScript workshop. That's it. And it's got instructions on each of the 8 steps throughout the workshop if you want to go and do them piece by piece. All the code snippets are in there that you would insert along the steps. They've got dev containers, so you don't need to install anything other than VS Code, Docker, and the dev containers extension. That kind of seems like a lot now that I say it. And you can run it in code spaces as well if you'd prefer. But then it'll set up the rest of it for you. And if you want to learn, the tool that I use to do this code generator is GraphQL Code Generator and GraphQLCodeGenerator.com. But there's the other one that I mentioned if you prefer to go down the code first approach. And lastly, I've been doing a series of blog posts around how we can use GraphQL on Azure that you'll find on my website at aaron-powell.com. And I think there's a link that'll probably pop up on the banners down below. There is the link to the first article in the series where we get started. And it doesn't look at necessarily this workshop in particular, but it looks at all things related to GraphQL on Azure, like how you can deploy GraphQL to Azure, how you can talk to databases. At the end of last year, I did one about how to integrate logging into a GraphQL server so that you can integrate that with Azure Monitor and get logging insights there as well.
Beautiful. That is perfect. Aaron, thank you so much for coming on, chatting a lot about GraphQL and TypeScript. I know I learned something, and we're going to have to figure out how to get you back on again sometime, hopefully soon.
I'm sure we'll find a reason.
All right. Thank you, Aaron. Thank you to everybody for tuning in. That is Web Wednesday. We're back next week to take a look at some cool 3D stuff that you can do in JavaScript. So I definitely hope you'll join. But in the meantime, thank you very much for tuning in. Bye.